Good morning, Year 10. Sorry, I can't be with you today for a live lesson. I'm with the key workers, so you've got a pre-recorded one. I am going to be available on email though, so do email me at red@theroyal.school if you do need any assistance with any of the work today. So we're going to have a look at some problem solving with our volume and surface area today. So we're going to be bringing together everything we've looked at over the past few lessons. Now the materials and the questions for today will actually be used over two separate lessons. So that'll be today. Wednesday is going to be PSHE, so it's today and Thursday's lesson that those materials will be used for. So I have a starter activity for us at the moment, which is on the screen. So if you'd like to stop this presentation until you're ready to go through the answers, that'd be absolutely fantastic. And if you're continuing, I will just assume that you're ready for answers on this. So to run through answers to this then, we want the total surface area of this cone. So we're going to need to know two things about it. We're going to need to know the curved surface area, which we should remember is pi r L, where L is the slanted length. We're also going to need the area of the circle at the bottom, and the area of a circle is pi r squared. So let's pop the values from our question into that. Pi is still pi, the radius is 10, and L, the slanted length there, is 18, and then the circle we need to add to that, so that's going to be pi, and the radius is 10, so that's pi times 10 squared. Well, 10 times 18 is going to be 180 pi for our curved surface area, and 10 squared is 100, so that's 100 pi for our circle. So this gives us 280 pi centimetres squared for our total surface area. So you're going to look at a question that's very, very similar to this. That's just got a little bit of a problem solving aspect to it for our next slide. So here we've got a virtually identical question here. So shown below is a cone. The base has a radius of 4, the slant height is y, so that's different here. We haven't got that given as a number yet. And we've got the total surface area of the cone is 48 pi centimetres squared. Calculate y. So it's a virtually identical question. We can actually set it up in exactly the same way. So don't get put off by the fact that we've got an unknown as our slant length there. We just need to run it exactly the same way and then just see what unknowns we have and where they are in our equations. So we said before that the curved surface area is that pi rl, and the area of a circle is pi r squared. And we're going to add those together to get our total surface area. So we're after pi rl plus pi r squared, but we know here that our total surface area is 48 pi. So let's put our numbers in from the question here. So the radius is 4, so we know this is pi times 4, and the curved, not the curved length, but the slanted length there, L, is actually letter y here in this question. So that's pi times 4 times y, plus pi times 4 squared equals 48 pi. Let's tidy up our algebra here. This is going to give us 4y pi plus pi 4 times 4 squared, so let's go back and write our 4 squared first. So that's going to be plus 16 pi equals 48 pi. What we can do is we can start to do a little bit of rearrangement now and try and get the y value on its own. So the first thing I'm going to do is take 16 pi off both sides. So we're going to need to do 48 pi minus 16 pi on the right hand side. So that's going to give us 32 pi. So we've got 4y pi equals 32 pi. I could now actually divide both sides by pi, and that's going to give us 4y equals 32. I can divide both sides by 4, and then that gives me y equals 8. And we're done. So don't get put off by unknowns being in your question. Just start to write out exactly the same formula that you would use if you knew all of the numbers. Then you'll just get yourself an equation there that you can start to resolve and rearrange so that we can let ourselves find that unknown. So y equals 8 centimetres. I can put down on the answer line. So another type of question here, very, very similar. The problem solving enough to put the algebra in these questions. So the cylinder above has a surface area of 400 pi centimetres squared. Calculate x. So again, you might want to have a look here at doing this question yourself. So if you're feeling quite confident, have a go at it first and then unpause the presentation. And if you do want me to run through this, then obviously carry on listening. So the cylinder above has a surface area of 400 pi. So again, it'd be really useful if we can get an expression for the surface area of this object. Well, surface area, we're going to need a circle at the top. and a circle at the bottom. We also need the circumference of a circle, and we times that by the height. And we do a curly x rather than a cross x, so we know the difference between multiplying and x's in our algebra. So this is going to give us, well, there's 2 pi r squareds there. This is 2 circles, and then there's 2 pi r x here, and we know this equals 400 pi centimeters squared. So what we could even do here is you could actually go through a little bit of a factorisation here. Both of the expressions here in the left hand side have a 2, a pi and an r in them. 2, a pi and an r. So I could rewrite it as 2 pi r plus x. That would work also. You don't need to do that step, but it might make things a little bit easier in the long run. So what is the radius? Well, you can see here that the whole diameter of the shape is 2x, so a radius would just be x. So this is 2 pi x brackets r plus x equals 400 pi. We've got another radius here that we can replace with x, so 2 pi x plus x equals 400 pi. X plus x in the brackets is going to give us 2x, and then we can multiply out the brackets there, and it still equals 400 pi. So the 2 times 2 is 4, so we've got 4 pi, and the x times x gives us x squared. I can now need to try and isolate x on its own, so I can divide both sides by pi to get rid of the pi, and I can divide both sides by 4 to give me x squared equals 100. And we should be able to spot from there that x is going to be 10. Now, of course, if you've got x squared equaling 100, your real answer should be x is positive and negative 10, but it doesn't make any sense in a shape question to have that. So we're going to leave x as 10, the positive number, as our answer. And that's it. So yet again, we're going to use just the straightforward formulas for our surface area. We're just going to leave those unknowns in there and then try and isolate or rearrange to get the unknown at the end. So that's most of our problem solving style of questions. So another one that you'd love to have is that you have one shape equated to another. So we've got 2 objects here that share the same volume, and again, it's going to be writing ourselves an equation, but essentially as soon as you work out one volume, you let it equal the volume of the other one. So we've got a cylinder of diameter 12 and height of 14. So how would you work out the volume of the cylinder? Well, it's going to be pi r squared h. How do you work out the volume of the cube? Well, it's just the side length cubed. And so we now have our formula to run with. So it says find y here. So let's put in any numbers that we do know. Well, we do know what the radius is. The whole diameter there is 12. So the radius is 6. We know the height is 14. And we don't know y. So same sort of idea again. In this case, we're going to be looking at a decimal answer here. We could leave things in terms of pi, but it probably won't help later on. So it's 6 squared times 14. So we've got 504 pi equals y cubed. So we need to cube root that now. I think whether you've left pi in your answer or not, once you cube root it, your calculator's not going to keep pi as part of the answer there. So as you say, to get y on its own, we need the cube root of both sides. Make sure my cube root sign goes over everything in the expression there. And that is going to give us, so we want the cube root, so make sure you know how to pop that in the calculator. And that's going to give us 11.655, so 11.66 to 2 decimal places equals y. And good. So you can see you need a thorough knowledge of volume and surface area of a lot of different shapes. They can throw anything at you. They can make up compound shapes. We could have had that cube stuck on top of the cylinder with some more values, and they could have said, well, what's the total volume? They could ask us the surface area of things. They could make like an ice cream shape by putting a hemisphere on top of a cone, things like that. You can see lots and lots of different problem solving questions appear. So last one I'm going to run through here, we've got a sphere, a cone and a cube. So this is quite an extreme version of these, and the surface area of the sphere is equal to the sum of the surface areas of the cone and the cube put together. So we need to just write out our formulas to start off with. Again, if you want to work ahead, if you're feeling confident, then pause the presentation and we can look through these in just a second. And I'm going to run through the answers now. So here we want to find y. So we're talking about surface areas. So the surface area of the sphere is the cone plus the cube. So write down the surface area of a sphere. Now this would be given to you in an exam question. I hadn't got room on here in case I needed to take up a lot of space for working out. You would be given that, and you should remember it, that it is 4 pi r squared. It was demonstrated on Musa and Evans' video when they were taking the orange peel off, and it fully fit into 4 circles of the same radius as the original shape. And we can get our surface area of the cone. Remember that it's the curved surface area plus the circle underneath, and then the surface area of the cube, which is going to be the length squared and then the 6 faces, so 6l squared. So what numbers do we have? Well, we've got 4 pi, I should have put there, sorry, let's put that in full. So 4 times pi times the radius squared, so that's y squared. Here we've got the radius given to us, so that's pi times 3 times 9 plus pi and times 3 squared. And here we've got our length as 8 squared. So 4 pi y squared equals, well, that's going to be 27 pi plus 9 pi plus, well, 8 squared is 64, so times that by 6 is going to be 384. So here, let's have a look what we're going to get. Now, we've got a pi over on the left-hand side, so it might be useful to divide by pi, but actually that's going to give us the 384 needs to be divided by pi as well. So we're going to struggle again with leaving pi as part of our answer in this. We're just going to have to let it occur that, we're going to get a decimal answer for this. So the first step is to sort of equate the left-hand side. I've got 27 pi plus 9 pi plus 384. So that's going to give us 497.097. There are a few more decimal places, so I wouldn't round this number just yet because we have to do a few more operations with it. So you can write it out as that, but keep it exact on your calculator. So that's 4 pi y squared. I can divide by all of 4 pi in one go, as I don't need to keep this answer in terms of pi. So divide that by 4 pi and you get 39.5577 and a few more decimal places. Again, I don't want that rounded at all because I still need to square root that answer to get y on its own. So square root both sides, and excuse that, didn't want a dotted line there. So we have y equals, that's going to be 6.289495, and again there's a few more decimal places, so then it doesn't ask us in this particular question, but you need to at least get your answer to 2 decimal places. So if I went to 2 decimal places, y equals 6.29. Make sure the point's visible there, and we put 2 decimal places. So if a question doesn't ask you for a particular level of accuracy, it's useful for you to actually put one in, but you also need to state what it is. So you could have gone to 3 significant figures, you could have gone to 4 decimal places, whatever you think is appropriate, but actually state that you've done that. So I wouldn't go to anything less than 2 decimal places really with an answer, especially if pi has been in terms of it, because it's going to be a number that carries on forever. So 2 decimal places, or at least 3 or 4 significant figures if you've got a really large number, going in there. And of course, if you've got something that does round to a perfect integer, then of course leave your answer as that perfect integer. So this should be a little run through of some problem solving skills you can use with volume and surface area. I've popped a worksheet, as I say, in learning. It's going to be Learning Cycle 3 Week 2 folder under today's date. There's about 15 questions I think they're on there, and they're all exam style, and so the timings that would allow are actually going to cover a sort of 2 lessons worth. So I'll be running through a few more different problem solving type questions during our next lesson, and there'll be a good opportunity there for people to ask for help. So if you do struggle with a question today and you feel like it's something you'd like to ask me verbally on the Teams meeting in our next lesson, then you can obviously hold on to that question until then. But please feel free to email me in the meantime. And good luck with the work here, because there's some quite tricky questions. Feel free to look back, as I say, at your previous work on volume and surface area, because there's going to be quite a few formulas you need to use on this. Thank you very much. I'll leave you to your own work now.